that having to memorize derivatives of functions was bad before. Welcome to lesson 5.11b, where we have to learn the derivatives of the inverse trig functions. There are 6 of them, and right now they're just sort of staring at you, saying, "Yay, try to memorize me." I understand these are really, really daunting looking, but the reality is we need to know them, and so we just kind of accept it. The one piece of good news is that, in my opinion, we kind of only need to memorize 3 of these. Because you may have noticed in looking at these, I assume that at some point you've paused the video and written these down. I've written them horizontally so that they're very similar to one another. Notice that the only difference between the derivative of arc sine x and arc cosine x is that arc sine is positive 1 over the square root of 1 minus x squared, and arc cosine is negative 1 over the same denominator. Right? Notice that arc tangent is positive 1, arc cotangent is negative 1. Arc secant is 1, arc cosecant is negative 1. So you'll notice all of the co-derivatives have a negative of their non-co counterparts, right? So it's sort of like if you can memorize the 3 that are over here on the left, you effectively have the same things for the one on the right. You just need to memorize that when you've got arc cosine, it's the negative of the arc sine formula. So once we have those committed to memory, it's really just a matter of taking the derivatives of these things. And the one warning that I'll give now is that remember that the product rule, the chain rule, and technically the quotient rule all apply here. I don't know that I'm going to give you any of these that actually require the quotient rule, but I figured I should mention that that does exist and is something that we should be prepared for. So I've got some examples lined up, and I figured we would take a look at those next. So the first example I want us to do is finding the derivative. So find f prime of x if f of x is arc cosine of 2x. I mentioned earlier that we need to pay attention to the chain rule, so this is a problem that has something plugged into arc cosine. I think the chain rule is probably the most common rule that gets used with these, so just heads up about that. So remember that the derivative of arc cosine is the one that's negative 1 over the square root of 1 minus x squared. So if I'm going to do the derivative of this thing, the derivative of arc cosine of 2x will be negative 1 over the square root of 1 minus, not x squared, but 2x squared. And then, because it's the chain rule, we need to multiply by the derivative of 2x, which is 2. Right? So all in all, this ends up being f prime of x is negative 2 over the square root of 1 minus 4x squared. And that's the derivative. So it's sort of like by virtue of the fact that the formulas for these things are so complicated, the problems themselves are generally pretty quick. There's generally not like a whole ton of simplifying. You're not going to have like mega super quotient rule to do for these, because to be honest, the problems are difficult enough on their own. I've got a few more lined up here that we can take a look at. The next one that I'll ask is find g prime of x if g of x is the arc tangent of the square root of x. That really didn't come out very pretty. That's the arctan of the square root of x. There we go. So if you're doing this at home, I'd recommend pause the video, try it on your own. It shouldn't take you long to work out this hint hint chain rule problem. So we know that the derivative of arctan, or rather we are slowly memorizing and recognizing, the derivative of arctan is supposed to be 1 over 1 plus x squared, but in this case it's the square root of x squared. And then we're supposed to chain rule, multiply by the derivative of what was inside. The thing inside was the square root of x, and the derivative of that is 1 over 2 root x. So if I simplify this a bit, this is 1 over 1 plus x times 1 over 2 root x. And so g prime of x is 1 over, I'd probably write this like this. And there it is. That's the derivative of the arctangent of the square root of x. Like I said, for as much as the formulas, the memorization is difficult, the actual execution of these problems I feel just isn't too big a deal. The next 2 that I have a little bit of a twist to them, so heads up on that. I was going to do my product rule one next, but I think I'll do another fairly simple one. So find h prime of x if h of x is arc secant of x squared. So arc secant is probably the most complicated one because it has x's show up in two different places. So we'll work carefully through this one. So when you're finding the derivative of arc secant is supposed to be, if you remember arc secant of x, it's supposed to be 1 over the absolute value of x times the square root of x squared minus 1. So when you have arc secant of x squared, that x squared is going to replace all of the x's in your derivative. And in some sense, that's the way that all of these things work, but I'll specifically mention it here. So this derivative will be 1 over the absolute value of x, which is x squared, times the square root of x squared squared minus 1. And then don't forget, we still have to do the chain rule. The chain rule here gives us times 2x. Right? So if I pretty this up a little bit, I've got h prime of x is 2x over, and this is where things get a little bit weird, this absolute value of x squared, because it's x squared, the absolute value, like x squared is always positive. Absolute value is effectively doing nothing for that thing. So we really just have x squared on the bottom, and then I have the square root of x to the 4th minus 1. And there's one more step that I can take here. There's an x on the top and on the bottom, so I can, those will eliminate one another, and I can end up with 2 over x times the square root of x to the 4th minus 1. And that's our derivative of arc secant of x squared. I have one last example. This last one is an example of a product rule, so I figured I'd give you one of those. So here we go. Find, I suppose we'll call it p prime of x for the product rule. Find p prime of x if p of x is x times the arc sine of 3x. Well, there are two things being multiplied, x and arc sine 3x. So when we take the derivative, we will take the derivative of the first thing, 1, and leave the other thing alone, arc sine 3x, plus, we'll leave the x alone, times the derivative of arc sine 3x. And again, if you're watching this at home, I'd recommend pause, try this one on your own, make sure you get all the pieces right. It's also a great time to practice having the things memorized. You'll have 1 over the square root of 1 minus, it's supposed to be 1 minus x squared, so this is going to be 3x squared, and then chain rule, because that's arc sine 3x, times 3. So p prime of x is arc sine 3x plus, if we look at this over here, there's an x and a 3 that are quote-unquote in the numerator, so I'll write 3x over the square root of 1 minus 9x squared. And there it is. Even when we have a product rule, like once you can get the formulas down, it's just not a big deal. I think that's all that I have to say here. I was thinking about including one other thing, but I think that'll do it.